everyone. Good morning, good afternoon, good evening. Today we are going to learn STP behavior in VPC. So when a VPC system is created, the VPC system is used to avoid the STP blocked ports, and hence it provides the layer 2 loop-free layer 2 topology. Now in a VPC system, the STP provides the following functions. First is it protects the layer 2 network by detection and breaking any loops before VPC configuration. It provides the loop-free path for non-VPC attached device. It manages the loop when VPC is added or removed. Now, while doing the STP configuration, it is recommended to configure some parameters on both sides of the peer switches. There are some global parameters. So in a global parameters, STP mode, STP region, bridge assurance setting, STP port type, loop guard, BPDU guard and filter, right? And in the interface setting, STP port type, loop guard, root guard, BPDU filter, BPDU guard. Okay. And if any of the parameter is misconfigured, then type 1 consistency error is detected, which we have already discussed, in the previous sections. So now let's see how VPC and BPDU, STP BPDU flow in the VPC domain. So even though VPC is configured on both peer devices, STP still runs and BPDU are still processed. Now in a VPC system, the primary switch are the responsible to reply for the BPDU, and it is the primary switch which sends the information of the root bridge to all Nexus devices across its layer 2 domain. Now whenever any secondary role VPC device receives any VPDU from the any access switches, this secondary switch, what it does, it proxies towards the VPC primary peer device. Now both VPC member port on a peer device always share a same BPDU port state. Now let's suppose, when a user configure a port channel as a VPC peer link. So this is your primary switch, this is your secondary switch. And as soon as this port channel is configured as a peer link, the bridge assurance feature already starts working, right? And this bridge assurance is a STP extension that protects layer 2 network from any unidirectional link event. So this protects a layer 2 network from any unidirectional link event, right, caused by control plane failure or physical link failure. Okay, now let's see how BPDU flows and the role of primary and secondary VPC peer device works in the STP. So in a VPC system, N7K is a primary. So let's suppose this is your primary and this is your secondary, and this secondary is root bridge. Now what happens? The primary will send a BPDU to all of its member port, whereas the primary will also send a STP BPDU at the, on the peer link. Whereas the secondary switch, which is also a root bridge, will send a BPDU to the peer link, as well as if it has any, non-VPC switch connected, it will also send a BPDU across it. Now, this disadvantage of this is that, let's suppose if this root bridge fails, right? So what will happen? It would cause a new convergence in the network, and during shorter period of time, some traffic would be interrupted. So to solve this issue, what we do, we configure a peer switch command. We configure a peer switch command inside a VPC. So doing so, what it will do, it will make primary switch as a root bridge, and it will also make secondary switch as a root bridge. So both, switches will be root bridge. Now what will happen? Let's see how the BPDU flows. The primary switch will send a BPDU towards VPC member port. The primary switch will send a BPDU towards the peer link, whereas the secondary switch, which is also a root bridge, will also send a BPDU towards VPC member port, and it will also send a BPDU towards a non-VPC connected devices. So only, thing is that this access switch will receive a 2 copy of the BPDU stating that which is your root bridge. So here, we have said, described the primary switch. It will send a BPDU to the peer link and the VPC member port. The secondary switch, which is a STP route, it will send a BPDU to the peer link and non-VPC member port and a VPC member port. This figure describes the same. Right now, we can also do the hybrid type of topology. So when a VPC peer switch is activated, both peer device must have a same spanning tree configuration, right? VPC peer switch supports hybrid topology. So if configuring a peer switch configuration, what it will do, it supports the hybrid topology, and this topology means, the both VPC attached access device and a STP attached access device, they both coexist in a VPC domain. So this is a picture of the hybrid topology, where a VPC devices and a non-VPC device, that means a STP attached device, they both exist in a VPC domain, right? Now, what is bridge assurance and how it works in a in a VPC? So what happens? So let's suppose if I state a scenario. So let's suppose this is your topology, and this is it's working, right? So this is switch 1, this is switch 2, this is switch 3, and this is your fiber link. So this is your TX, this is your RX, this is your TX, this is your RX, this is your TX, this is your RX, RX, TX, TX, RX, RX, and TX. So now this port is blocked port, right? And the BPDU is being shared between all these devices, right? Now let's suppose a series of event happens. Let me change the color. This switch to control planes hangs, or any problem in the control plane of the switch. So in that case, it will not be able to send a BPDU here. It will not be able to send a BPDU here. So once this switch 2 is not able to send a BPDU to switch 3 because the switch 3 has a blocked port. Switch 3 will wait till max delay, timer is expired. Now, once the max delay timer is expired, this port will come into the forwarding state. Now, when this port comes to the forwarding state, right, all the ports are in forwarding state, and if there is any, broadcast packet is created, the loop will be created. So in order to avoid the, loop in the Nexus domain, bridge assurance, feature came into the picture. So what happens, as soon as I configured a peer link, right, the BPD, the bridge assurance feature is enabled on the peer switches, and on rest of the port channel, you have to configure a bridge domain. So how it works? So let's suppose I have a switch 1, I have a switch 2, I have a switch 3, and I have a cable connected. Now, if anything goes wrong to the control plane of switch 2, and the switch 2 is not able to send any, BPDU, so on the receiving side, that means on a switch 1 side and a switch 2 side and switch 3 side, because the bridge assurance is configured, the bridge assurance will move this port into the blocking state. So this both port will be moved in a blocking state. So in that way, the loop has been avoided. Now, as soon as you restart the switch, and you made some changes, you do any, power restart or whatever you do, and you make this control plane available, and this switch is functioning normally. So as soon as the switch 2 functions normally, it will start sending a BPDU again here. It will start sending a BPDU again here. So as soon as switch 1 and switch 3 start receiving a BPDU, these port will come into the forwarding state again. Okay, so this is how, the bridge assurance works in the VPC. So thank you for watching STP behavior in a VPC. Thank you very much. Take care. Bye bye.